Hello and welcome to Easy Projects. So you might have noticed that I haven't put up a video for a while, and it's simply because I haven't had time to get anything done, except this part. I've been busy at the uni making assignments and projects and preparing for exams, and I still am, so there probably won't be a video for another month or so. So I thought I would just show off some of the things that I have been working on, and starting with this one, it's kind of an experiment I'm going to do. So you can put some fluid in one end and get it out the other end. And no, it's not for a computer, but it is for cooling something. And that'll be the next thing coming up. But it's probably not what you think. And also for a completely unrelated project, I bought one of these fog machines that I'll have a play around with. So I also thought I would include something that I don't usually show, so I'll show some of the projects and assignments I've been working on since I don't have anything else exciting to show. So I usually don't put these videos on here because I don't like having videos where I just show things off without telling how they work or how they were made or something like that. It has to, people has to get something from it instead of just watching something. But I've also been wondering what I could put on my Patreon page. I don't want to take anything away from the YouTube, of course, because I still want it to be free. So I guess I could put those kinds of videos on Patreon, just showing off random stuff at random intervals. Until now I haven't put anything on there, so at least I think there should be something for those who donate directly. And also a quick thanks to those who support me on Patreon. People generally don't seem to leave even though I haven't uploaded videos in, is it 2 months now? So a huge thanks for that. But I do have a lot of stuff queued up that I want to make videos about, so it's just a matter of getting time to do them. There's definitely a lot more to come. Anyways, let's take a look at those clips that I promised.
So the first clip here shows a project that we made for user experience design. We wanted to make a lighting solution for very long halls or staircases or anything like that, where you want to turn the lights off when nobody's there to save the power. But then our system should be pleasant for the user to use instead of usually in long hallways. You have a sensor turning on a few lights at a time. If it's a 50-meter hallway, then you only want to turn on the lights where people are. In our system, the lights should follow the user and gradually turn on the lights in front of them. Of course, this is just a prototype and small-scale test. In the real world, the lights should be a lot further ahead also, instead of just a few meters, but since we only had 10 meters to do with, we made it shorter just to show the effect. So the second project is an analog PID controller that we made. It's supposed to keep the fan in a fixed angle. We can set that with a potentiometer, and no matter what load we put on it, it should regulate and keep the fan in the same position. It's not entirely perfect, but at least we got it to work. Ideally the overshoot that you see in the beginning is not supposed to be there, but yeah, it's good enough. No worries.
So this is my solution to the fifth exercise in interaction design for embedded systems. This is about moving objects, and I decided to make a gauge. It's digitally controlled, but it should resemble an analog gauge, so it can it works like an old style voltmeter or ammeter. It's controlled with a servo motor on the back side, glued to a piece of acrylic, and the needle is also acrylic. So the idea behind it is, if this was a fuel gauge, for example, if this was digital and just showing numbers, then those numbers might not mean anything to you. Say it said 250 liters. But looking at this, you could see that the system is about half full, and once we get down here, it starts to get empty. And if the digital display is showing like 10.5 liter, perhaps you wouldn't know if that's close to empty or whatever if you don't know the system. But with this analog style gauge, you got the range as a reference. So this is design 6 for interaction design for embedded systems. And in this exercise we build upon the one from the previous design, the gauge that I made here, and we add sound and light to it. So if we still imagine this as a fuel gauge, when the gauge is high like this, it's just green, meaning that everything is okay. And the backlight also serves the purpose that we can see it in a dark environment, like this one. And when we turn the gauge down to 35%, it becomes yellow. I know it looks a bit reddish up here and a bit green down here, but it should have been yellow. And when we turn it further down, it becomes red, below 20. And the buzzer is beeping. When we turn it further down below 10%, it starts blinking and beeping faster. And of course, if we refuel the system, it becomes yellow and then green, and it stops beeping also. So here's my 7th design for interaction design for embedded systems. And now I replaced the potentiometer with a bending sensor. And this changes resistance when it's bent. So if you bend it one way, it decreases, and the other way it increases. And by using a fixed resistor, we can make a voltage divider with this and read it with the ADC on the microcontroller. So as you saw, we're now able to control the gauge with this bending sensor. So we can go from full all the way to yellow and to red. And it should, it's hard to keep it there, but it should beep. And when we go all the way down, it should beep fast. So for the 7th and final design in interaction design for embedded systems, I replaced the potentiometer that I used to control the gauge with a bending sensor. So I was thinking what this sensor could be used for, and I finally decided to make a system that can help the user to move a bit, for example when watching a movie in the television, so you don't sit in the same position all the time. Then the sensor will monitor your movements. It could be embedded into a cloth or something like that. And then when you move, it will decrease this gauge, and when you sit still, it will increase it. And if you sit still for long enough, it will start to warn you. And if you keep sitting still, it will start blinking and beeping faster. And since this is just a test, I made the timer very fast, so it goes very fast from being okay to being that you need to move. So let's test it. I just taped it to my finger here, so I'm able to bend the sensor. So it starts off in the green area and it drops down, and if I move the finger, you can see it goes back up. And if I hold the finger still, it goes towards yellow and then red, and it starts beeping slowly, and then it beeps faster and blinks. And then if we move the finger, it goes to the green again. So that's it. I hope you liked it. So thanks for watching this video, and I hope to see you in the next one. See you.